All right, this is Honors Algebra 2 Pre-Calculus. We're doing 5.3 in Algebra 2, which is more factoring. Specifically, we're going to focus on factoring quadratic trinomials in this video, which is going to be a pretty lengthy video because this is a skill that we can show in a bunch of different ways, and I'm going to show you a couple ways. So there are many ways to logic through factoring quadratic trinomials. I'm going to walk through a few here. Moving forward after this video, I'm only going to factor using my preferred method, which you can either call educated guess and check or the unfoil method. It's the way I was originally taught. I will show you other options, and I don't care how you factor. I care that you factor correctly, and then you get quick at it because it's going to become an early step in very long multi-step problems later on. So I don't care how you do it. One of my students for years has used a method. She just graduated a year ago, and she used a method that, like, legit, she'd explained to me like 20 times, and it just did not jive with my brain, but it always worked, and it was completely reliable, and her way did not make sense in my head, but it was great, and whatever teacher taught it to her, it made sense to her, and as long as it's right, that's great. You want to be right and fast, and the only way that it's not okay to be right is if you're looking at somebody else's paper or like Googling the answer, right? So as long as you're doing your own work, I don't care what method you're using. So let's go ahead and walk through. So I'm going to walk through fully factoring each of these using my method. Notice that I didn't put any steps, right? And the reason I didn't do that is because it's easier to explain this in words out loud than it is to write this. So here are two different ways to factor this, okay? So here's what I do. So this is the unfoil method. That's what I'm going to call it, right? So unfoiling. The unfoil method is about recognizing that this x squared plus 5x plus 6, if it factors, is going to factor into two binomials, right? A front seat and a back seat in each of these binomials, right? So if I choose to do it this way, here's the idea. I recognize that this is the f part of FOIL, and that the only way to get an x squared in this case is an x times an x, so my front seats must be an x and an x. I also recognize that this is the L part of FOIL, and the only ways to multiply to 6 are either a 1 and a 6 or a 2 and a 3, right? I notice because there is a plus sign, this plus sign tells me that whatever sign the back seats have, it has to be the same sign. Because the only way I can get a positive 6 is if they are both negative numbers, like -1 and -6, -2, -3, or they are both positive numbers, like 1 and 6 are positive and 2 and 3 are positive. Once I know they're the same sign, I know that they have to add to a positive 5. Well, that means that this sign must tell me they're both positive. Because if they're both negative, there's no way they add to a positive 5. So now it's my job to guess and check and figure out which of these two combinations, either 1 and 6 or 2 and 3, fits best in these two spots. Now, most of the time, I'm going to suggest that you guess the middle set of numbers first. The reason I suggest that is that more often than not, it is the two numbers that are closer together. It is not usually the 1 and the 6, it is usually the 2 and the 3. Sure enough, if I try 2 and 3 here, right? So this is my guess. I'm then going to FOIL to check, right? X times x gives me x squared. X times 3 gives me the 3x. X times 2 gives me the 2x. And 2 times 3 gives me the 6. Sure enough, that's an x squared plus 5x plus 6, check. So this is my answer. Now, I don't generally do this on paper. I usually do this in my head. I do a quick FOIL to check that I'm right. Keep in mind that if you set up the outer and the first and the last correctly, if you followed these logical rules to make sure they work, then really you're only checking that the OI works. You're checking that the OI gives you that 5x, and it does. Now, that's the way I factor. It's very fast. It sounds slow when I walk through every single step, but as you get better at doing it and you're not articulating it to an entire class of people, you'll be surprised to find how much faster it is. Now, there are other ways to do this. Keep in mind that this is the easiest kind of factoring example where this leading coefficient is a 1, and that's going to matter. It matters that this is, so this is easy-ish, like this is on the easy side because a is 1, right? It's an x squared with a 1 in front. That's going to make this problem much easier. When I start putting a number that's not 1 in front of x squared, it's going to be harder. So let's use one of the various product sum methods, okay? So this is the other kind of methods you're going to see. So product sum basically involves recognizing that if you have ax squared plus bx plus c, so my a is 1, my b is 5, and my c is 6, you'll see these in two different ways. You'll either see them with this X kind of chart, right, where they're going to say something like product a times c, right? So a times c would be 1 times 6, which is 6, and a sum of b, which is a positive 5. And then, so that's one way you'll see it. The other way you'll see it is as a t-chart, where you see a product of a times c, which is 6, and a sum of positive 5, right? And basically what you're going to do, I personally, of these two, I like the t-chart better. And the reason I like the t-chart better is because I can list the numbers that multiply to 6 really easily, right? 1 and 6, 2 and 3, -1 and -6, -2 and -3. And then I look at these and I say, hey, which of these three has a sum of 5? Oh, it's this set. So 2 plus 3 is the only set of numbers that would work, because these guys don't work. But the same idea here, if you try to pick magic numbers that have a product of positive 6 and a sum of positive 5, sooner or later you're going to land on 2 and 3, right? So either way you choose to do this, you now have these things that a lot of people will call like the magic numbers. Okay, so the magic numbers are 2 and 3. Once you find that those magic numbers are 2 or 3, basically what you're going to do is what's called factoring by grouping, which we're going to cover in a later video. You're going to take this 5x and you're going to split it into these two numbers, the 2 and the 3. So what that's going to look like, and again, this is not the method I advocate, not because there's anything wrong with it, but just because I don't think it's as quick and it's not the way I learned it, and it's fine. Any way you can factor is fine. So you're going to take this original expression, this x squared plus 5x plus 6, and you're going to split the 5x into the two magic numbers that you just found. And it doesn't actually matter what order you write them in. So it's a positive 2x and a positive 3x plus 6. And then what you're going to do is you're going to factor this in two groups and look for a group GCF. If you take a GCF out of just these first two terms, you take out an x and you're left with an x plus 2. Right? If you take a GCF out of the second two terms, you get a 3 and you're left with an x plus 2. So now, just like you saw in one of the early examples in the last video, I now have this weird GCF in the parentheses. The x plus 2 is the same factor in both parentheses. When I factor that out, I'm left with an x plus 3, and that is my factored form, which you'll notice is the same answer that I got when I did it my way right here, right? Again, I don't use product sum, but you absolutely can, and we're going to walk through some harder examples of product sum too. Cool, so P3, you can pause me, factor it any way you want, right? I'm going to list both ways in a sec just to show you, but again, in the long term, I'm not going to suggest that you use two ways. In fact, I'm never going to suggest that you ever use two ways. I'm going to suggest you pick a way and get really good at it. So when I unfoil, right, unfoil is built on the idea that this is my first terms, right? So the first terms in my parentheses, the only way to get an x squared is going to be an x and an x, right? My last term is a 7. Well, the only way to get a 7 is a 1 and a 7. This plus tells me that they have the same sign, and since they have to add to a positive 8, that sign has to be positive. So I know they both have a plus sign, and because 7 is prime, I don't even have any choices. It has to be a 1 and a 7. This is my factored form. Now you can FOIL to check, right? If you FOIL, you're going to get an x squared plus a 1x and a 7x, which is definitely your 8x, plus a 7, and that's definitely right. If you chose to do it with product sum, right? If you do it with product sum, I'm going to pick the t-chart, but again, I don't care if you like the other way. So I need a product of 1 times 7, which is 7. Well, the only way to get a 7 is either a 1 and a 7 or a -1 and a -7, right? Like those are the only two options, 1 and 7 or -1, -7. And since I need a sum of b, which is 8, this is the only one that gives me a sum of 8, right? So once I know that, I split the 8x into those two numbers, so I get x squared plus x plus 7x plus 7, right? I split that 8x into these two numbers, and I find a group GCF. I pull an x out of here and get an x plus 1. I pull a 7 out of here and get an x plus 1. Now this new GCF is the group x plus 1, and I am left with this x plus 7. Notice it's the same answer. Again, I don't care how you get there. What I will say is that the unfoil method, I don't actually show any of this work if I'm not doing it for you, right? I just look at this and say, oh, hey, it's this, and I'm done, right? Okay, let's go ahead and do something, again, not necessarily slightly harder, but same idea. So now we have a y squared minus a 5y plus a 4. So I'm going to go ahead and do my way, and I'll also walk you through the other way. We'll do product sum. Again, I'm not going to do this forever. I'm just going to do it for this video so you see the options. So y squared minus 5y plus 4. Okay, so I recognize that my front seats have to be a y and a y, right? There's no way around that. The only way I can get a y squared is if I have y times y, right? And we'll talk about what happens when there's a number in front in a minute. my back seats, right, the last is either 1 and a 4 or a 2 and a 2, and we're going to find out which in a second. I know from the plus that they have the same sign, but this time they're adding to a -5, so that tells me that the signs are negative. So I now have to say, cool, is it the 1 and the 4 or the 2 and the 2? Well, if I try the 2 and the 2, because I told you generally try the middle set of numbers first, that's not going to work. Because the outer, if I have a 2 there, outer is going to be y times -2, which would be -y, and the inner would be a y times -2, which would be -2. That'd be a -4y, which is not what I want. So it's not those. So it must be the 1 and the 4. When I check this now, the outer is the y times the -4, so -4y. The inner is the -1 times the y, and that is my 5y, right? It's my -5y. So my answer ends up being y minus 1 times y minus 4. And it doesn't matter if the y minus 1 is in front or the y minus 4 is in front, because this property is multiplication, so it's commutative, right? So that's fine. That's one way to do it. If you chose to do it the other way, if you chose to use product sum, that's absolutely fine. If you chose to use product sum, my A is 1, my B is -5, my C is 4, right? So I would need a product of A times C, which is a 4 times 1, or 4, and I need a sum of, I thought I said -5, but I seem to have written 5. So -5. So it's either a -1 and a -4, a +1 and a +4, a -2 and a -2, or a +2 and a +2. Well, when I look at these, the only one that sums to a -5 is the -1 and the 4. So I would take this y squared minus 5y plus 4, and I split this term into those two magic numbers. So y squared minus y minus 4y plus 4. I look for a GCF of the first two terms, and it's a y, and I'm left with a y minus 1. I look for a GCF of the second terms, and I get a -4, and I'm left again with that same y minus 1. It's not an accident that this y minus 1 is the same. It needs to be in order for this to work. And once I factor that out, the only thing left is the y minus 4. And then sure enough, you'll see that I get the same answer. Again, it wouldn't matter if you had reversed the order of the two answers. So let's go ahead and do P4. Same idea, right? So I have this x squared minus 15x plus 50. I know that my front seats have to be an x and an x. I know that my back seats, now 50 has a bunch of options, right? It could be 1 and 50. It could be 2 and 25. 3 doesn't work, 4 doesn't work, but 5 and 10 work. Now, chances are by visual inspection, you spot that it's 5 and 10 pretty quickly, right? I notice that they're the same sign, and then that minus tells me what the sign is. I'm pretty sure that a 5 and a 10 would give me a -15 if I add them together, right? Now, sure enough, if I check, right, when I FOIL, I get x squared. The outer and inner, outer is going to be a -10x and a -5x, which is exactly what I need. And then my last term is a plus 50, so it works, and that's my answer. Now, you might not spot that it's the 5 and the 10 right away, and that's fine, right? I would say that as you do this, you tend to get better at it, and you're more likely to spot the answer. Now, if you chose to do this using the product sum method, right, if you want to do this using product sum, your A is 1, right? So you'd need a product of A times C, which is going to be a positive 50. You'd need a sum of -15, and then basically you're going to end up making the same list you just made over here, just on the table, right? You're going to have a 1 and a 50. You're going to have a -1 and a -50. You're going to have a 2 and a 25. You're going to have a -2 and a -25. You're going to have a 5 and a 10. You're going to have a -5 and a -10. Sorry, it's a 10. And sure enough, ignore me, that did a thing that it wasn't supposed to do. Sure enough, when you do this, the one that ends up working is this one. And so then you take this and make it an x squared minus 5x minus 10x plus 50. You take out the GCF of x and you're left with an x minus 5. You take out this -10 and you're left with an x minus 5. See how those are the same big blob of math, and what you're left with is an x minus 5 times an x minus 10, same answer. Cool. All right, moving on. All right, so now it gets a little bit tricky, and this is the thing that makes it harder, is that now you're going to have opposite signs. So let's walk through a slightly harder example. So when I go to factor x squared minus 4x minus 12, let's make some observations. The first observation is that my front seats have to be x and x, right? Because the only way to get an x squared is an x times an x, so my front seats are x and x. But the back seats are now tricky. The last terms could be a 1 and a 12, a 2 and a 6, or a 3 and a 4. There's a lot of ways to multiply to get 12s. But in addition to that, I noticed that they have opposite signs because that's the only way I get a negative sign out. So what that means is that I don't need two numbers that add to -4. I really need two numbers that subtract to -4, and I'm pretty sure it's these guys. These guys will subtract to -4, right? Like if I do it in the right order, they'll subtract to -4, specifically a -6 and a +2. So one of these needs to be a -6, and one of them has to be a +2. When I FOIL to check, right, my first terms are x times x, which is an x squared. My outer and inner are a +2x and a -6x, which is sure enough my -4x, right? And then my last is a -12. So x squared minus 4x minus 12, that's correct. All right, so if we do this the other way with product sum, it's the same idea, right? So if I did this with product sum, and again, I will not always do these using both methods, I need stuff that multiplies to a 1 times -12. So I need a product of -12, and I need a sum of -4. So I know that I could have a 1 and a 12 where the 1's negative. I could have a 1 and a 12 where the 12's negative. I could have a 2 and a 6 where the 2's negative. I could have a 2 and a 6 where the 6 is negative. I could have a 3 and a 4 where the 3 is negative, or I could have a 3 and a 4 where the 4 is negative. So then I look at all these options and say, cool, which of these adds to -4? And this is the only one that does, right? So I then take my x squared, I take this -4x, and I split it into these two things, a +2x minus a 6x minus a 12. I look to take a GCF from each piece, and from here I get an x left with an x plus 2, and from here I get a -6 and an x plus 2. When I take out this new group GCF of x plus 2, I'm left with an x minus 6, and sure enough, that's the same answer. Again, it doesn't matter that they're in the opposite order because multiplication is commutative, right? It matters that each entire term, like each entire factor, the x minus 6 is one factor, the x plus 2 is the other. It doesn't matter what order I write them in. Cool. All right, so again, same weird tricky thing, right? So go ahead and give this a try. You can pause me if you want. I'm going to start with my unfoil method, and I'll do it in both methods. So x squared plus 10x minus 24. My first terms have to be an x and an x. My last terms have to be a couple things. They have to be opposite signs. And then 24's got a lot of options. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Good times. Okay, but because they're opposite signs, what that means is I need them to subtract to a +10. Right? That's what I'm looking for, is a combo that would subtract to +10. So I have this x, and I look and see which of these numbers could possibly subtract to a +10, and I'm pretty sure that it's the 2 and the 12 with the 12 minus the 2. So I need a +12 and a -2, and sure enough, if I FOIL to check, that's my answer. Now, again, I don't show all this work if I'm doing this on my own paper, right? Like nobody wants to see that on a test. Even if the question is factoring, I just need to see that you factor it right, okay? I don't need you to articulate full sentences. I don't need all of this stuff. If you jump from here to here, nobody thinks you're cheating, right? But you do need to be able to factor. So if you jump from this thing to this answer, nobody thinks you're cheating. That's okay. Now, certainly there are harder things to factor when we get to stuff with synthetic division where you're going to have to show a little bit of work because it's a little bit more difficult. This is not meant to be something that's a ton of work, though. So if you did this with product sum, right, your product would be a times c, which again, a is still 1, so that hasn't been a big deal. So it'd be -24. Your sum would be a +10. You would list all of these same values that I listed over here, but eventually, after listing a ton of values, like a 1 and a -24 and a -1 and a 24, blah, 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 you'd have a 2 and a -12, and then finally you'd get to -2 and +12, and that would be your winner, right? And there are more, right? There's a 3 and a -8, and there's a -3 and an 8, and there's a 4 and a -6, and there's a a -4 and a 6, right? But at the end, this is the winner. So you're going to make this x squared minus 2x plus 10x, plus 12x, my bad, miscopied my own number, minus 24, right? And then I'd look for a GCF here. I'd pull out the x and be left with an x minus 2 plus the 12, and I'd be left with an x minus 2. I yank out the x minus 2, and what's left is this x plus 12, And look, it's the same answer. Again, it doesn't matter that it's in the opposite order because multiplication is commutative. All right, so let's go ahead and segue into the next thing that's going to make things a little bit more difficult, right? So now all of a sudden my a is no longer 1, and that's going to make a big difference. So now I have a 3x squared plus a 5x plus a 2. What that means is that my first terms have to be a 3x and an x. And my last terms have to be a 1 and a 2 with the same sign. So what's funny about this is that this problem is actually a lot easier in some ways because there aren't a whole lot of options, right? I know that my front seats have to be a 3x and an x. I know that the signs are the same, which tells me that the plus sign is the sign I'm using. And then really the only question is which one of these gets the 1 and which one of them gets the 2? Is it a 1, is it a 2 and a 1, or is it a 1 and a 2? Those are the only two possibilities, right? Well, I noticed that I want a 5. I noticed that I want a 5x. So I say, well, if I put the 2 over here, I'm going to get 6x and 1x, which would be 7. So I need the 1 to be over here and the 2 to be here. What that'll do is when I check my outer and my inner, that's going to give me a 3x and a 2x, which is a 5x, and that's the right answer. If we do the same method using, or the same problem using product sum, right? So if we tried to do this using the other method. Now here's the first time that product sum is going to be a little different, because remember, you need a product of a times c, right? AC. Well, a is 3 and c is 2, so I need a product of 6, and I need a sum of b, which is 5. So now I'm going to recognize that this could be a 1 and a 6, a -1 and a -6, a 2 and a 3, or a -2 and a -3, right? So once I recognize that, I say, okay, this is the only one that has a sum of 5, right? So 2 and 3 must be my magic numbers. So now I take this 3x squared, I split the 5x into a plus 2x and a plus 3x, right? That's what that 5x is going to be, and a plus 2. So now I take out a GCF from each of these two sets, and I get an x times the quantity 3x plus 2, plus the only GCF here is a 1 times the quantity 3x plus 2, which means that when I take out this big GCF in the parentheses, 3x plus 2 times x plus 1, and sure enough, there's the same answer, right? Again, I don't care what method you use, I just care that you're able to do it. So let's walk through a P6. Again, pause me if you want. So I'm going to walk through it my way, and then we can walk through it the other way as well. So my front seats have to be a 2x and an x. My back seats have to have the same sign, right? And they could either be a 1 and a 10 or a 2 and a 5, because those are the only ways to multiply to 10. I see that they have the same sign and that the sign is positive. So what that tells me is that if I set up my set of parentheses, right, I have a 2x in one of my parentheses and an x in the other. I have a positive sign in both, right? And then when I look to see how I could possibly get a 9, right, I realized that the best way to get a 9 is if I use the 2 and the 5, because if I put the 2 over here, I get a 4x, and a 5x would give me 9, right? Because this would give me 4x, this would give me 5x, and that is my 9x, right? So there's my factored form. Again, I don't check as often as maybe some other people do, because I do a lot more math than normal people, because, you know, high school math teacher. But you should always do a quick FOIL in your head, right? Even if it's just really quick, because you're going to be super mad if the reason that you get an entire calc problem wrong is because you accidentally factored wrong on the first step. So my product is a times c, which is going to be 20. Oh, we're frozen. Sorry, we're beach balling. There we go. A times c, which is 20. And my sum should be b, which is 9, right? So I think most of us would pretty quickly get to the 4 and the 5, to be honest. Like, you could list all the numbers, but I think you're going to get to 4 and 5 pretty quickly. So when you get there, this is going to be a 4x plus a 5x plus a 10, right? You're going to group each one, take out a GCF of 2x and be left with x plus 2, take out a GCF of 5 and also be left with an x plus 2. So now when you yank that x plus 2 out, you're left with a 2x plus a 5, which again is the same answer. All right, cool. We're going to do an E7 and a P7, and then that'll be the end of this fairly lengthy video. Okay, so now this one's tricky, because now not only is my A not 1, but I have opposite signs, right? So now suddenly things are getting a little bit tricky. So 4n squared minus 15n minus 25 is tricky on 3 different levels that I can think of. First level it's tricky on is that A is not 1. The second level of it being tricky is that there are actually two ways to get this first term. It's either a 4n times an n or it's a 2n times a 2n. There are two different options, right? Back here, my last term is either a 1 times a 25 or a 5 times a 5. Yet again, oh sorry, that's not an F, it's an L. Come on, brain, I said last. Okay. But it gets further tricky because I see that the signs are opposite. So what that means is I need things that subtract to a negative 15, right? The opposite signs mean they have to subtract to a negative 15. So now let's walk through setting this up. And this is sort of the perfect storm of this problem getting harder. So I recognize that most of the time, not all of the time, right? But most of the time, I'm going to guess the middle numbers first, right? I'm going to guess the middle numbers. Now, that doesn't mean it's right, but I'm going to try them and see if they work. So if I tried a 2n and a 2n, right, but had opposite signs, what I'm going to notice right away is that with the opposite signs, this would be a difference of squares, right? That's a nope, because this is a difference of squares pattern, right? And it can't be a difference of squares pattern, because if it's a difference of squares, the OI cancels, right? So the OI equals 0 in a difference of squares, right? And we know that the OI is not going to be 0 because it's supposed to be a negative 15, so it's definitely not that option. But I mentioned it because I want you to see that you usually guess the middle numbers first. So I'm going to guess that because these guys are both multiples of 5, the 15 and the 25, that I probably want to pick the 5 and the 5 still, because it makes a lot of sense to me that chances are I'm combining different multiples of 5 to get the 15. So I'm going to keep the 5s and I'm going to try the 4n and the n. So if I try that, 4n and n, I know that if I'm trying the 5s, they're both 5s, and then I would be trying opposite signs. Well, these guys together give me a 20n, and these guys together give me a 5n. I want two things that would subtract to a 15. Sure enough, if the negative 15 rather, if the 20 is negative and the 5n is positive, I would get a negative 15n. So I want the 20 to be negative, which means I put the negative here so that the 4 times the negative 5 gives me a negative 20, and the positive here. And sure enough, if I FOIL to check, that's my answer. You can tell that it's a lot harder when all of these things are factors, right? So this is hard for three reasons. The opposite sign makes it hard, the fact that neither 4 nor 25 are prime numbers makes it hard, and the fact that 4 is not a 1 obviously makes it difficult. Now, if you chose to do this the other way, using product sum, let's just walk through that real quick. So if you chose to do this the other way, what's going to happen is you're going to end up wanting to have a sum of negative 15 and a product of a negative 25 times 4, which is negative 100, right? So if you list things that multiply to 100, right? 1 and 100, right? 2 and 50, 3 doesn't go into 100, 4 and 25, 5 and 20, and that's your winner, right? Because what you're noticing, if you notice from this that you want opposite signs, you could say, hey, I get it, it's this one, I want the negative 20 and the positive 5, right? So when I list this, I'm now going to make this 4n squared minus 20n plus 5n minus 25. I take out a GCF from these two of 4n, and I'm left with n minus 5. I take out a plus 5 from these two, and I'm left with an n minus 5. So now I have this group GCF of an n minus 5 times the 4n plus 5, which is the same answer that I got by my guess and check. All right, let's bust out one last one real quick. We're going to do a P7. So same set of tricky things, right? Opposite signs, non-prime here, non-prime there, A isn't 1. So 6x squared plus 7x minus 49. Right? 6x could either be, 6x squared rather, could either be a 6x times an x or a 3x times a 2x, and I don't know which yet. 49 could either be a 1 and a 49 or a 7 and a 7. It's probably not the 1 and 49 given how small the 7 is. I know that this tells me the signs have to be opposite, so what I need them to do is subtract to 7, right? Subtract to a positive 7. So if I'm guessing, I'm going to try the middle numbers first, right? Just like I did last time, I'm going to try the 3x and the 2x, and I'm going to try the 7 and the 7, right? 7 and 7. So if I tried multiplying the outer terms, this would be a 21x. The inside would be a 14x, and sure enough, these would subtract to a positive 7 if I make the 21 positive and the 14 negative. So I'm going to make the 21 positive and the 14 negative, and that's going to be my answer. If you chose to do this using product sum, it's going to pan out pretty much the same way, right? You're going to make your table, you're going to list things that multiply to whatever 6 times negative 49 is, which I don't feel like doing off the top of my head right now. So you're going to have to figure out those numbers, right? That's going to be the product. And you're going to want a sum of 7. And I'm going to be honest, it's going to take a while until you get the numbers that are going to work for that, right? It's going to end up being a 21 and a negative 14. After you list a ton of other numbers, it's going to look like that, and then you're going to factor using product sum, but it's going to be difficult. So we'll call it there. I think that you kind of get the gist. Well, I'll finish this out real quick, actually. So plus 21x minus 14x minus 49. Take out the group, which would be a 3x, and this would leave me with a 2x plus 7, and then this I would take out a 7, and I'd be left with a 2x minus 7, plus 7, my bad. All right, and so then when I take this thing out, right, I get 2x plus 7 times 3x minus 7, and that's the same answer, just in the opposite order. All right, that's it.